So I also got just 10 minutes, so I'll speak pretty quick. Don't think just as Marcia, but yeah, you already passed one slide for me. So I'm going to talk about distributed tracing. Few things about me. It's running by himself. Few things about me. I'm the CTO here at Heptagon. I've got vast experience in cybersecurity. I'm raising and training a guide dog for blind people constantly, and I'm trying to look for whales in Hawaii here, but unfortunately I haven't found any. So let's get to the bottom of the talk. So usually I'm trying to explain what serverless is to a friend, but I don't have time for this, so we'll skip it. Also, I like to talk about the evolution of serverless and how do we got here, but I don't have time for it, so let's skip it. And why serverless is good, I think everybody already talked about it and you're familiar with it, so let's skip it as well. And as everyone did so far, we'll talk about what's distributed tracing and visualizing serverless, or let's say distributed applications. And that's the right point. Everyone is talked about what they're thinking of serverless is. I'm gonna say my words about it as well. I think that serverless applications are composed with several resources. Some of them are compute, can be function as a service, container as a service, can be composed with resources like databases, managed queues, message queues, and machine learning stuff, and so on, that somebody managed for you, and managed APIs, Stripe, Twilio, Auth0, and so on. All this composing a serverless or managed applications, which we see nowadays. Let's try to troubleshoot the first scenario here. Before I'm going to talk about distributed tracing, I'm going to give a scenario where it can fit and where it's relevant. So troubleshooting distributed applications, everyone agreed that it's not the fun part. Let's start with a scenario. We're getting a message. Personally, I really love Sentry. It captures all the errors that I have. Not that I have, I'm a good developer when I'm developing. So we get a JSON decode error, and now we need to roll our sleeves and find out what is the problem. We know where it happened in a specific Lambda, so we'll get to the logs of this Lambda stored in Elastic, so I'm getting into the Kibana, but then I'm ending up with like tons of logs, and I'm like, where is the problem? What happened before that? There are lots of problems with the logs that I can't really know what's going on because there are tons of them, and I think it comes up to the factor that they're not structured. I mean, I can't ask meaningful questions about them, like give me all the logs that relates to an operation against a DynamoDB, which was a put operation and took more than the amount of time that I want. I can't do this in logs unless I'm explicitly writing a log line that's mentioning explicitly that. Other than that, we've got many resources and many compute units and many ways to ingest logs from so many endpoints, and trying to look at all of them in the same place, it's like a chaos. You don't have any correlation, you don't have any context, you'll find out yourself just toggling your head against the wall and trying to figure out who published that log and where is it and why it's there and so on. So instead of trying to solve this problem, let's introduce distributed tracing and automated instrumentation, which this is the main reason of the talk over here. So distributed tracing will tell us a story of a chain of events, even if they're asynchronous to each other, a chain of events over the system, over a few spans, starting, let's say, from the client in this example, all the way to the load balancer and some other services that were involved in this trace or this distributed trace. To achieve distributed tracing, there are some standards. We don't need to reinvent the wheel. Probably the most common one is open tracing, which defines a standard of how to capture this kind of information in a way that we will know how to track each and every service along the way. It's obviously manual. It just defines a standard, and you need to capture all these events. You can do that by open census, which helps with some instrumentation. And instrumentation, in a few words, it's the ability to capture requests or events at the system in an automated way. For example, if I want to capture an HTTP request, I want to capture the status code and the URL that I'm handling with, and how long the operation took. And it means that for every request, before and after the request, I need to capture that and also inject some IDs all over the way, so I'll be able to know that I'm part of a different trace or different transactions. This requires high maintenance, obviously, and potential of missing some errors if I haven't captured them correctly. And just as an example, you don't really need to read this, but just to handle an HTTP request, this is the code that I need to do just to capture all the information. Adding all of this all over the code is like too many annotations, too many work. And honestly, when you're talking about serverless applications or managed applications, you're having lots of functions, lots of resources, lots and lots of APIs. And we all agreed that we want to focus on what's the most important, and it's to deliver software faster. And when you're getting this kind of application, instrument and distributed, building your own distributed tracing to this one, it's almost impossible. This is, by the way, the part of the backend of the Hexagon application, and it's really hard to keep track of what's going on there. The right way to do this, so we learned the tools, but let's see how we should tackle these kind of problems once they happen. Instead of just jumping to the logs and trying to find something meaningful in the logs, let's first see the traces story. So the trace story, as we saw before, the example that we saw with open tracing, we want to see the chain of events, like what happened, which resources were involved, how long it took. So starting from this example from with API gateway and Lambda function and some external HTTP resources, and even spanning over asynchronous events. For example, if I put a message to an SNS, I want to see who put this message and who read this message, like the publisher and consumer. And same applies for any kind of async resources. And on the right-hand side, you want to see the payload or the details of these specific events. And now when I want to see the logs, let's say, for example, I want to see the exact logs of this specific invocation of this specific Lambda function, I want to get them specifically. I don't want to scroll through endless logs and try to filter them and don't get the idea. I just want to see them exactly. So this was the first example. The second one is performance monitoring in distributed applications. Well, the problem of almost any developer here in the room. And let's start with having an architecture, just to know what's going on, and somebody tells you, hey, I'm getting slow responses from your website or from your API endpoint, and you're like, I don't know where even to start. I'll start to print some logs, I'll start to get some ideas, but then you ended up that your Lambda function is running slowly, and it has like 3 or 4 resources that it's talking to. And by the way, before diving into that, if you're interested in front-end libraries that can allow you to build this kind of charts, Cytoscape, Viz.js, D3, and Sigma are great tools to accomplish that. But obviously, you need to give them the data. It won't scan your AWS account or your code. And the main question we left up is where our code spends our time, why the customer is waiting a few seconds to get a response, what's taking so long. So the right way to do this is by looking at a timeline view or trace view, or it has some other names as well. And in this example, we can see that the first Lambda, the request processor, which is the upper bar, has 2 main operations. One calling off 0 for authentication, and the other one is publishing a message to an SNS because we want to create an asynchronous chain of events. And in this example, it's pretty easy to grasp that the most of the time is being spent on off 0. The request, the external request, our user waits 300 and something milliseconds just for this request to be processed. In this example, we could easily say, let's switch a service, or let's cache it, or let's do something that will improve the performance, because we can easily detect where our code spends the most of the time. To display this kind of timelines, there are great tools such as Jaeger and Zipkin, open source, freely open source. They will allow you to ingest traces in the open tracing format and display them according to what you see over here. And just to sum up, because I think it's running out of time, distributed applications are here, and you need the right distributed tracing tool to monitor them and get over these kind of challenges so you won't get up in the middle of the night trying to understand what's going on. And the key for success is visualizing the data correctly. Visualize it whether in a graph, in the architecture graph, or a way to detect performance issues using the timeline view, or even troubleshoot stories rather than logs. Nobody likes to read logs in the middle of the night. I prefer to see that visually, so I'll be able to know where the problem located. As I mentioned, I'm coming from Hexagon. We're doing this kind of instrumentation and distributed tracing, everything that comes out of the box for you, and visualizing the data. Most of the screens that you saw are coming from Hexagon. And thank you very much.